Today we're going to take a look at evaluating and graphing linear functions. Now when you see that word evaluate in algebra here, all it means is we are plugging in values for our variable. So let's take a look at numbers 1 through 4 here. We're going to evaluate the function for the given value of x. And actually that should say for the given value of the variable there. Because we can plug in numbers for x or for y or for whatever variables they give us here. Okay. And the only thing confusing here might be being able to read what the problem actually says. So for number 1, it says here's our function y is equal to x minus 5. Then we have a little semicolon x equals 3. Okay, this semicolon x equals 3 tells us that we want to plug in the value 3 into our function for x. So if we were to do that here, okay, we're going to rewrite the function, but instead of writing x, we're going to plug in a 3. So we get y is equal to 3 minus 5. Okay. And then we simplify what we can. So if we do 3 minus 5, if we KFC that, it's the same as 3 plus negative 5. And 3 plus negative 5 is going to tell us y is equal to negative 2. So when x is equal to 3, y is equal to negative 2 for this function. It actually works both ways here. Number 2 says here's our function y is equal to 3 times x. But for this one, they want us to plug in negative 12 for y. So if we plug in negative 12 for y, we're going to rewrite this function replacing y with the value negative 12. We get negative 12 is equal to 3 times x. And then that just becomes a one-step equation to solve for x. So to get x all alone, we have to get rid of a times 3. To get rid of a times 3, we're going to divide by 3. And if we do that to the right-hand side, we have to do the same thing on the left-hand side. Okay, if we simplify this, negative 12 divided by 3 gives us negative 4 is equal to, on the right-hand side, 3 and 3 cancel. So we bring down our x. So for this function, when y is negative 12, x is equal to negative 4. Number 3 says take the function y is equal to 1 minus 3x and plug 4 into that function. So if we go ahead and take our function and we're going to replace x with 4, it's going to look something like this. Y is equal to 1 minus 3 times 4. Okay. Order of operation says we're going to do our multiplication first, so we're doing negative 3 times 4, so that gives us y is equal to 1. Negative 3 times 4 is negative 12 or minus 12. And then to simplify that, 1 minus 12, which is the same as 1 plus negative 12, should give us the value for y, which is negative 11. So for this function, when x is equal to 4, y is equal to negative 11 here. The last function here, we have the function y is equal to 2. And they want us to plug in 6 for x. So this is a little bit challenging here because if we look at our original function, y is equal to 2, okay, there is no place for us to plug x into that function. So we really can't do anything with this. There's no place to plug x in, so our final answer there is just going to be y is equal to 2. So when x is equal to 6 for this function, y is going to equal 2. So in that instance, there will be times where your value of x, you won't be able to plug it in to your function. Okay, let's scroll down here and take a look at why this is a valuable skill to know, to be able to evaluate, plug in values for variables here. One of the main reasons that this is a valuable skill to know is because it allows us, we can use this method of plugging in values for variables into all different types of functions to help us find their graphs. So for 5, 6, 7, and 8 here, we're going to graph the given function, and we're going to do it using an XY table by evaluating values for x. So take a look at number 5. We have the function y is equal to x plus 2, and we want to create an XY table to help us graph that. So if you remember back to chapter 4, when we create an XY table, we can go ahead and pick any values for x that we want to plug into this function. Okay, I for me, I always like to do a couple negatives. Always plug in 0 because that's an easy one to plug in. And then we'll plug in a couple positives. Okay, so basically this is what we did on problems 1 through 4, just repeated 5 different steps. So for the first one, we're going to plug -2 into our function for x. When we do that, we get something that looks like this. Y is equal to -2 plus 2. And if we evaluate that, do the math there, -2 plus 2 gives us 0. So when x is -2, y is going to equal 0. And these actually create an ordered pair for us here. So this is going to become one of the points on our graph here, the point -2, 0, which is we go left 2 and up 0. So there's our first point. We're going to repeat that process for all of our different values of x. If we plug in -1 to our function for x, we get y is equal to -1 plus 2. And -1 plus 2 is going to give us +1. So when x is -1, y is going to be +1, which gives us the ordered pair there, -1, 1. And if we were to graph that, we go left 1, up 1, and there's the second point on our graph. Okay, now let's go ahead and plug in 0 into our function there. So if we plug in 0 for x, we're going to get y is equal to 0 plus 2. 0 plus 2 is 2. So when x is 0, y is 2, which gives us the ordered pair 0, 2, which is right here on our y-axis, over 0, up 2. You can kind of see the pattern starting to develop there in our graph. This is a linear function, so we should be getting a straight line there. Okay. Next value we're going to plug in is 1 in for x. So if we plug 1 in for x, we get y is equal to 1 plus 2. And 1 plus 2 gives us the value 3. So we get the point when x is 1, y is equal to 3, or the point 1 comma 3, which means we're going to go to the right 1 and up 3, and there's the next point on our graph. And one more value to plug in. We're going to plug in x is equal to 2. So if we plug in 2 into our function, we get y is equal to 2 plus 2, and 2 plus 2 is 4. So when x is equal to 2, y is going to equal 4, giving us our last ordered pair. 2, 4, right 2, up 4, make a point there. Okay, there is the graph of our function y is equal to x plus 2. The nice thing about this method is it allows us to graph functions of all different shapes and sizes, like I said earlier. Today we're going to only be working with linear functions, but as you get into deeper levels of math, you'll be able to use this method of plugging in values into your function to find ordered pairs on a graph. Okay, let's take a look at number 6 here. For number 6, we have the function y equals -x minus 2. And if you recall, we can rewrite this one as y is equal to -1 x minus 2. Okay. And the only reason I like to do that is because this negative sign out in front of our x tends to give students trouble from time to time. So if we rewrite it as -1 times x minus 2, it kind of reminds us that we need to do order of operations when we're evaluating values here. Okay. Let's take a look at graphing this function. So first up, we're going to pick a couple different values of x. Let's go ahead and pick. We'll just use the same ones. Okay, those are typically the easiest to use. Okay, but I'll show you some instances where it's better to use different values. Okay, so we're going to use -2, -1, 0, 1, and 2. And we're going to plug each of these values into our function one at a time. Okay, so I'm going to actually plug them into this function. Y is equal to -1x minus 2. So if we plug -2 in for x here, okay, it's going to look something like this. Y is equal to -1 times -2 minus 2. And order of operations says we're going to do our multiplication first. So -1 times -2 is 2. We're going to bring down our minus 2. So we get y is equal to 2 minus 2. And 2 minus 2 is 0 there. So if we plug -2 into our function, for x, we get the y value 0, giving us the first ordered pair in our function, -2, 0. So let's go ahead and graph that. That's to the left 2 and down 0. Okay, let's go ahead and plug in -1. I'm going to do a little erasing here to give me room to work. Don't erase your work on your assignment there. Let's plug in -1 for x. So y is equal to -1 times -1 minus 2. -1 times -1 is 1. Bring down our minus 2. And 1 minus 2, or 1 plus -2, is going to give us y is equal to -1. So if we plug in -1 into our function for x, we get the output, or the y value, -1 for y. And that point is going to be left 1, down 1 on our graph. Now let's go ahead and plug in 0 into our function for x. If we plug 0 in for x, we get y is equal to -1 times 0 minus 2. And -1 times 0 is 0. So we get 0 minus 2. And 0 minus 2, or 0 plus -2, is going to give us y is equal to -2. So that gives us the point 0, -2 on our graph, which is over 0, down to right there on our y-axis. 2 more to go. Let's plug in 1 for x here. If we plug in 1 for x, we get y is equal to -1 times 1 minus 2. -1 times 1 is a -1. Bring down our minus 2. So we're looking at y is equal to y is equal to -1 minus 2, which is the same as -1 plus -2. So if we plug in -1, or if we plug in 1 into our function, we're going to get y is equal to -3. Okay. And a good way to tell that whether or not you're doing this right is this should be a linear function. So when we're graphing these points, if we go right 1 down 3 to our next point, we should be getting points all in a line there. Okay, last value to plug in here, we're going to plug in 2 for x. So if we plug in 2 for x, we're looking at y is equal to -1 times 2 minus 2. So y is going to equal -2 minus 2. And -2 minus 2 is going to give us -4. So we get the value 2, -4 for our last point. If we go right 2, down 4, looking good there. It's still right in line with the rest of our points. Let's draw a line through this, put arrows on the end. Hey, there is the graph of the function y equals -1x minus 2. So a lot of this is carryover from what we did in Chapter 4, but this skill comes up over and over again, so it's a good skill to keep practicing. All right, going down here to number 7, I'm going to have to do a little bit of erasing here because the program is not being friendly. So I'm going to erase this, scroll down to 7 and 8, and we will finish up the rest of this chapter, or this section here. All right, scrolling down to 7 and 8. For number 7, we are looking at the function y is equal to 1/2 x. So let's go ahead and pick some values for x to plug in here. This is one of the cases where I'm not going to plug in -2, -1, 0, 1, and 2, just because I want the numbers to come out nice and neat. So for this problem, I'm going to plug in 0. I always like to plug in 0. Let's go ahead and plug in numbers where when we multiply them by 1/2, which is the same as dividing them by 2, we're going to get nice, neat numbers. So how about we plug in 2 and 4? Those are both going to be divisible by 2. Give us a nice, neat integer. Okay. And then let's do a -2 and a -4 up there. All right, plugging in values starting with -4 for x, we get y is equal to 1/2 times -4. And 1/2 of -4, or which is the same as -4 divided by 2, is going to give us y is equal to -2. So there's our first point. And next we're going to plug in -2 for x. Y is equal to 1/2 times -2. 1/2 of -2, or -2 divided by 2, is going to give us a -1. Okay, plugging in 0 for x, we get y is equal to 1/2 times 0. 1 half, or anything times 0 is going to give us 0 there. So y is equal to 0 for our third point there. The next value, if we plug in 2 for x, y is equal to 1 half times 2. And 1 half of 2, or 2 divided by 2, is going to give us 1. And lastly there, y is equal to 1 half times 4. If we plug in 4 for x, 1 half times 4, or 4 divided by 2 is 2. So there's our last point, the point 4, 2. If we were to graph these, the first point, negative 4, negative 2, is left 4 down 2. Then we have negative 2, negative 1, left 2 down 1, 0, 0 right there at the origin, followed by right 2, up 1, and right 4, up 2. Line through it, arrows on the end. There's the graph of our function y is equal to 1 half x. Number 8, we are given the function y is equal to negative 3. So let's go ahead and plug in values for x. I'm going to go back to plugging in negative 2, negative 1, 0, 1, and 2. Now you might recognize this as one of those special lines that we talked about in Chapter 4, but if not, okay, this method of evaluating values for x can help us figure out what kind of graph it's going to be. Okay, so just like we talked about in number 4 on our notes, we have the function y is equal to negative 3, and we're going to try and plug in negative 2 for x. But there's nowhere up here in our function, there's no x's up there to plug it into. So since there's no x to plug in our value to, doesn't matter what x is, y is going to equal negative 3. Okay. Same thing for the next point. There's no place to plug negative 1 in for x, so y is going to stay negative 3. And it stays negative 3 for whatever values of x we pick. Now if we go to graph these points, so we have our first point, negative 2, negative 3, left 2, down 3, then left 1, down 3 for our next point, 0, negative 3 right there on the y-axis, 1, right 1, down 3 for our next point, and the last point, right 2, down 3 right there. Okay, you can see that that's going to give us a horizontal line. Okay, so if you see a function like this and you're not sure what type of line, if it's going to be horizontal or vertical, you can always plug in values for x. Use this method to kind of reason through it. Taking a look at last two problems here in our notes, 9 and 10, it says complete the table for the following function rules, making sure we show our work. So this is pretty much what we did on the front side. If we want to complete this table in number 9, all we we're plugging in these values into our function for x. So if we plug in negative 2 for x, we get y is equal to 5 times negative 2 minus 3, which is negative 10 minus 3, or negative 13. And if we plug in negative 1 for x, we get y is equal to 5 times negative 1 minus 3, which is negative 5 minus 3, or negative 8. So we get negative 8. If we plug in 0 for x, y is equal to 5 times 0 minus 3. 5 times 0 is 0. And 0 minus 3 is going to give us negative 3. If we plug in 1 for x, we are looking at y is equal to 5 times 1 minus 3. 5 times 1 is 5 minus 3. And 5 minus 3 is 2. And then lastly, if we plug in 2 for x, we get y is equal to 5 times 2 minus 3. 5 times 2 is 10. And 10 minus 3 is going to give us 7. So y is equal to 7 there. So that's exactly what we did on the front side, just without having to graph it. Okay, last one here, number 10. We have the function y is equal to x plus 4, and we want to complete the table. So first one here, it says plug in negative 2 for x. Negative 2 is one of our x values, so if we plug in negative 2 for x, we get negative 2 plus 4, and negative 2 plus 4 gives us a y value of 2. The second problem here is a little bit different. We want to know when y is equal to -1, what x is going to be. So in this case, we're going to plug in -1, not for x, but for y, and then we're going to solve for x. So -1 is a y value. So if we plug that in for y, we get -1 is equal to x plus 4. And then our one step to get x all alone, to solve for x, we're going to subtract 4 from both sides. We get -5 is equal to x. So it works both ways. If they give you an x value, you can plug it in for x to find the y value. If they're giving you a y value, you can plug it in for y and do a couple of steps to find the matching x value. Continuing on with number 10, we want to plug in 1 for x. So y is equal to 1 plus 4. And 1 plus 4 is 5. So when x is 1, y is 5. Okay. Next one, we're going to plug in 1 for y this time. 1 is a y value in this case. So if we plug in 1 for y, we get 1 is equal to x plus 4. Subtracting 4 from both sides, we're going to get -3 is equal to x. So when y is 1, x is equal to -3. And lastly here, we're going to plug in 5 for x. So when we do that, we get y is equal to 5 plus 4. 5 plus 4 gives us y is equal to 9. Okay, so when you're working with tables, it works both ways. That's important to know. You can plug in values for x to find missing values for y, or you can do the reverse. You can plug in values for y to find the missing value of x.